Hello everybody, this starts our new section in our new unit actually. So new section and new unit. It's going to be all about rational functions and solving. But to start off, we're going to be doing one day on simplifying rational expressions. So this will just be a single day, and then tomorrow we'll start 6.2. Simplifying rational expressions. Let's first talk about the how. We are going to factor the numerator and denominator and cancel out common factors. So our how, the tool in our toolbox for today, will be to factor the numerator and denominator and then cancel out common factors. So let's get right into our examples. We will have a total of 9 of them. So here's number 1. 4x squared divided by 20x to the 5th. So let's see. It says factor the numerator and denominator, but these are monomials. So let's see what we can do. I see 4 20ths, and I know 4 goes into itself once and into 20 5 times. So 4 20ths can simplify to 1/5. And now looking at x squared divided by x to the 5th, from my exponent properties, I know that these two x's will cancel with 2 of these 5, leaving 3 behind. So let's see what we have remaining as our answer. In the numerator, 1 will stay as a placeholder, and in the denominator, I have 5x to the 3rd. And we are done. It's as far as we can take it. We have successfully simplified that rational expression. Number 2. 4x to the 7th plus 16x, all divided by 20x to the 5th minus 8x to the 3rd. So I recommend looking at the numerator and denominator as separate pieces. So what I mean by that is, if I'm looking at the numerator, for right now I'm going to ignore everything I see in the denominator. I see that I have a binomial here, 4x to the 7th plus 16x. So let's see what we could factor out. What is our GCF? Well, I see 4 and 16. I know I can factor out a 4. There are 7 x's here and 1 here, so I can factor out a single x. Seeing what's left, dividing both of these terms by 4x, 4 divided by 4 is 1. Remember that when we are dividing x to the 7th by x, you're subtracting the powers, or you could see it as there were 7 x's, I took out 1, that leaves 6 behind. 16 divided by 4 is a positive 4. And then again you could say x divided by x, those cancel out, that's a 1. Or you could say there was 1x, I factored out a single x, none are left. Let's repeat that process with the denominator, 20 and 8. Just looking at the numbers first, 20 and 8. What can I factor out? At first I might think 2, but what's wrong with thinking 2? Well, I'm looking for the greatest common factor. So what is a larger number that factors out of 20 and 8? And I'm hoping we're thinking 4, because I agree. So I can factor out 4, x to the 5th and x to the 3rd. How many x's can I factor out? I can factor out 3 of them. And then let's see what's left. 20 divided by 4 is 5. There were 5 x's. I factored out 3 of them. That leaves behind 2. Or You could say x to the 5th divided by x to the 3rd results in x squared, your choice. 8 divided by 4 is 2, so minus 2. There were 3 x's, I factored out all 3, none are left. So remember, we are able to cancel factors. What I mean by that is this says 4 times x times this whole piece. But notice this is addition. Same thing down here, 4 times x to the 3rd times this piece. We can't touch anything that's over subtraction or addition. We can only focus on what is being multiplied together, the factors. So when I look here, I see that 4 and 4 cancel because 4 divided by 4 is 1. This x will cancel with one of these, leaving 2 of them behind. Our result will be x to the 6th plus 4, all divided by x squared times, and this wasn't touched, 5x squared minus 2. Number 3. 3x squared plus 6x, all divided by 9x cubed minus 3x squared. Please press pause and try this one on your own, using number 2 as an example. Please press pause now and try number 3. So for number 3 again, I see that I have a binomial divided by a binomial, so I'm going to be focusing on finding the GCF. Just looking at the numerator, 3x squared plus 6x, I can factor out a 3x, which will leave behind x plus 2, all divided by, now let's take a look at the denominator, 9x cubed minus 3x squared, I can factor out a 3x squared. That will leave behind 3x minus 1. Once again, we cannot touch anything that's over addition or subtraction, so I am just paying attention to these factors out front. The 3's will cancel. This x will cancel with one of these, leaving 1 behind. So our result will be x plus 2 in the numerator divided by x times 3x minus 1. Number 4 says x minus 4 all divided by x squared plus x minus 20. So now we need to start recalling our knowledge of quadratics and factoring. The numerator I can't do anything with, so that x minus 4 will stay. Here I see a is 1. So that means, recall, I'm looking for factors of c that add to b. So I'm looking for factors of negative 20 that add to a positive 1. What are we thinking? Factors of negative 20 that add to a positive 1. I'm hoping 4 and 5 come to mind, where 4 will be negative. The resulting factors will be x minus 4 times x plus 5. So now we're very much doing the how part we discussed here at the top. Factor the numerator and denominator and cancel out common factors. So here we factored the denominator. What do you see is a common factor? Well, I see up here in the numerator I have x minus 4. This is being multiplied, right? I've got a multiplication symbol right there in the middle. We just never actually write in that multiplication sign. So these are factors. So that means that this factor can cancel with this factor, leaving behind 1 divided by x plus 5. Number 5. 4x squared minus 23x minus 6, all divided by x minus 6. Looking to factor, let's first check for a GCF. I see 4, negative 23, and 6. Is there anything I can factor out of 4, 23, and 6? The answer is no. So for this one, A is not 1. We will need to guess and check. Outer, inner, equals middle. Let's recall what we mean by that. So I will set up my two parentheses. I'm going to start off with 4x and x as factors. I'm strategically doing that because technically, right, I could have written 2x and 2x because that also equals 4x squared. But if I look at the denominator, notice I have x minus 6. So if I have any hope of having a factor cancel, it's going to be with 4x and x. So I choose to try that first. Factors of 6 that I might try are 3 and 2. And maybe I decide to try putting 3 here and 2 here. I'm going to pause right there again. Remember, we're looking for possibly x minus 6 to cancel. So I might say, you know what? I leave 3 and 2 on the back burner, and I'm going to try 1 and 6. Because if a 6 can go here and a 1 can go here, I might be in really good shape to have this factor cancel with that one in the future. And for it to cancel, I would have to say, can that be negative and can that be positive? So let's see. Let's guess and check the outer. So the outer gets me negative 24x, and the inner would get me a positive 1x. That does get me the negative 23x I needed, so I'm in good shape. That is still all divided by x minus 6. And now, what can cancel? As I had hoped it would work out, my x minus 6's cancel, leaving behind 4x plus 1. Number 6. 2x squared minus 7x minus 15, all divided by 2x squared plus 5x plus 3. Both, if I look at these right now, 2, 7, and 15, no GCF, and then in the denominator, 2, 5, and 3, again no GCF. So please press pause now. For the numerator and denominator, you will be factoring A is not 1, guessing and checking, outer, inner equals middle. Please don't press play until you have both the numerator and denominator factored. So I'll start factoring and see if I match you. I'm going to set it up 2x and x, and when I think 15, I really don't have anything to help me out because I'm going to have to factor this too, but I usually think 5 and 3. So I'm going to try putting 5 here and 3 here. Outer gets me 10x. The inner gets me 3x. To add to that negative 7, the 10 has to be negative, and I get the negative 7x I need. That 10 came from 5 right here, and this would be positive. And I know that I'm in good shape to have 1 negative, 1 positive because C is negative. Moving on to the denominator, I will set up the same parentheses. And now I can be a little strategic because I'm dealing with 3, and the only factors are 1 and 3. So if I'm going to have factors cancel, this has to be 2x plus 3. So I'm going to try first to see if putting 3 here will work because then I would be able to cancel. So let's see. Outer gets me 2x. Inner gets me 3x. I'm trying to get to a positive 5x. C is positive. I get to have both of these be positive. So I know I am good to have plus and plus, which strategically worked out great because now I'm going to look for factors that will cancel, and I see that 2x plus 3 will cancel with 2x plus 3, leaving behind x minus 5 divided by x plus 1. We can take that no farther. Number 7. 7x plus 35, all divided by x squared plus 5x. So we're taking a step back into looking at some binomials, which means my very first action will be to check for a GCF. So I'm going to actually ask that you try number 7 on your own, look for a GCF in the numerator and denominator, and then see what might cancel. Please press pause now. Checking for GCF in the numerator, I see that I can factor out a 7, which leaves it behind 7 times x plus 5. And that's all going to be divided by, let's see, x squared plus 5x. I can factor out an x. That will also leave behind x plus 5. Check that out. X plus 5 will cancel with x plus 5, leaving 7 divided by x as my answer. And hopefully we match. You'd be like, yay, we got the same answer. I'd be like, yay, you did, good job. Number 8, x squared minus 36, all divided by x cubed minus 216. So now we're really bringing back some prior knowledge. Because I'm hoping right away we recognize x squared minus 36 as the difference of two perfect squares, which will be x plus 6, x minus 6. I am also hoping that the denominator is ringing a bell, because it is the difference of two perfect cubes. So what number cubed gets me 216? Think, think, think. If you're writing in pencil, commit to an answer. Let's see what you write. The answer is 6 cubed. So we can write x cubed minus 216 as x to the third minus 6 to the third. Difference of two perfect cubes. And who remembers how that factors? If you remember, take a guess right here, put it down, and then we'll see if we match. The difference of cubes is, by definition, a minus b times a squared plus ab plus b squared. So we will be using a is 1, or excuse me, a is x, and b is 6. So let's see how that will work. A minus b becomes x minus 6. A squared will be x squared, minus ab is minus 6x, plus b squared is plus a 36. We have successfully factored the difference of cubes, and now let's see what factors will cancel. I see x minus 6 can cancel with x minus 6. Is this factorable? Thinking back, I know that whenever we factor the difference of two perfect cubes, automatically this is not factorable. I can go no further, which means my final answer will be x plus 6, all divided by x squared minus 6x plus 36. Last example for today is number 9. And number 9 says 2x cubed plus 7x squared minus 10x minus 35. All divided by 2x cubed plus 7x squared plus 6x plus 21. As soon as I see 4 terms, I'm hoping that we are thinking back to our toolbox and recalling how to factor by grouping. So my first group, again, I'm just going to pay attention to the numerator, is 2x squared plus 2x cubed plus 7x squared. What can I factor out of that first group? I can factor out x squared. So I'll factor out x squared. That will leave behind 2x plus 7. And now looking at the second group, which is right here, what can I factor out of negative 10x minus 35? From that, I am able to factor out a negative 5. Which will leave behind 2x plus 7. Please press pause right now and you work on factor by grouping in the denominator, and then we'll see if we match. So looking at the denominator, looking at this first group, 2x cubed plus 7x squared, once again I can factor out x squared and it will leave behind 2x plus 7. From the second group, 6x plus 21, I know that I can factor out a 3 because that's the largest value that divides evenly into 6 and 21. That will leave behind 2x plus 7. We have not finished factoring by grouping yet. So again, I'm going to come back up here and just look at the numerator. And I see 2x plus 7 is my common factor. So factoring out a 2x plus 7 from the numerator will leave behind x squared minus 5. Looking at the denominator, once again, I will look for the common factor. And here I see again that 2x plus 7 and 2x plus 7 is common. So I can factor out 2x plus 7. That will leave behind x squared plus 3. Now we have successfully factored by grouping. Sometimes people only take it this far and they get stuck. You actually have to finish, we did the grouping part right here and factored out from each group, but then to finish factor by grouping, you actually have to see what's common that I can factor out and then what's left behind. In the denominator separately again, what's common and then what's left behind. Now we can go back to seeing, do I have any common factors? And the answer is yes. I see that we can cancel 2x plus 7 with the result of x squared minus 5 divided by x squared plus 3. I check for difference of squares. 5 is not a perfect square. This is the sum of squares. We have no rule for the sum of squares, so I know that I cannot take this any farther. Always good to check though. That wraps up our simplifying notes and looking forward to practicing. Great job. Any questions on the notes? As always, please shoot me a question on Remind. Have a great day, everybody.